Hi everybody. In this video we are going to go over composition of matter. So matter is always made up of elements. The definition of an element is something that cannot be decomposed by ordinary chemical means. So for instance, table salt. Table salt is sodium chloride, NaCl. Well, I can break that up into sodium and chlorine pretty easily by very simple chemical means. What I can't do is then take that sodium and break that apart into something else. That would take a lot of energy to start to destroy that. That's actually what radioactivity is. Uh, because uh, because elements are made up of protons, neutrons, and electrons, and to break that apart is not a normal thing. Again, that's radioactivity. So again, elements are made up of atoms. Atoms are the smallest particle of an element that has all the properties of that element. So again, if I break an atom up, then it no longer is that kind of element. Now, that being said, I can monkey with atoms. So atoms are made up of protons, which are the positive little particles in an atom in the nucleus. They're made up of neutrons, which are the neutrally uh, charged molecule or little particles in the nucleus of an atom, and electrons, which are the negatively charged particles that surround the atom. Now I can mess with protons and I can mess with neutrons. If I start to mess with protons, then it changes the element entirely. So for instance, I believe that oxygen is atomic number 8. It has 8 protons. If I make it have 6 protons, it is no longer oxygen. Okay, but I can change the amount of electrons, so the charge of that atom, or I can change the number of neutrons or the mass of that atom. And we'll talk about those neutrons after a bit, but right now we're going to talk about ions because these are pretty common things that happen to atoms. So an ion is just an atom or a molecule with an electrical charge. So if you look at, let's just take the most simple of the elements, hydrogen. It's 1 proton, 1 neutron, 1 electron. Awesome. Well, because the electron has 1 negative charge and the proton has 1 positive charge, they cancel each other out. So an elemental atom of hydrogen has no charge to it. But if I take the electron away from it, it's going to have an overall positive charge now. That's an ion. Okay. And atoms become ionized, if you will, so charged, oftentimes when they go through some kind of chemical reaction. So if you kind of generally look at the periodic table, the metal atoms tend to lose electrons, and these are the mostly here. So these are the true metals on the far left. These are metals. These are metals also, but they're a little bit squirrely in the middle. They don't necessarily do what you think most metals will do. These are the transition metals over here. But these metals, so let's say for instance, sodium. Anytime sodium goes through some kind of chemical reaction, it's going to lose an electron. And that's why it's in this very first column. It means it has 1 valence electron and it wants to give it away like crazy. Okay, lithium same way, potassium same way. So so if I make table salt and I add sodium, which has 1 valence electron to give away, and I mix it with chlorine over here, which wants to gain 1 electron, then this sodium ion, which loses an electron, is going to become positive. This chlorine would become negative. Okay, so metal atoms pretty much always lose electrons. Whereas non-metal atoms, which are mostly here, gain electrons. Okay, so they would become more negative because they're gaining a negatively charged particle. So because you can have either a negatively charged particle or a positively charged particle, atom and or molecule, we have categorizations of ions. So the types of ions can be described by charge, which would be a cation. It's not cation, which kind of looks like, it's cation. A cation is a positively charged atom or group of atoms. So for instance, hydrogen. If it goes through a chemical reaction, it will pretty much lose an electron. It becomes positive. Magnesium, it will lose 2 electrons. These are considered kind of metals, even though hydrogen is a gas. The anions are the negatively charged atoms or group of atoms. So these are atoms or group of atoms that have gained electrons. So for instance, chlorine, as I mentioned, chlorine has 7 valence electrons. It wants 1 more to get 8. So it will gain an electron like crazy. So it becomes -1. Oxygen has 6 valence electrons. It wants 2 more to get 8. So it will gain 2 electrons, which again, electrons are negatively charged. So anything that has a net positive charge is a cation. Anything that has a net negative charge is an anion. I can also categorize ions by the number of molecules in them. So for instance, a single charged atom is called a monoatomic ion. So for instance, barium has a +2. Okay, it doesn't mean it has nothing to do with the charge so much. It has to do with this is just 1 atom of barium. That's it. Okay, because it has a positive charge, it would be a cation, and so you could describe this as a monoatomic cation. Whereas bromine wants to gain 1 electron, and so it does, and that's where it gets that -1 charge. You notice the 1 is not there because you just put negative, it just means 1 negative. But it's gained 1 electron. The electron has a negative charge to it, so this would be a monoatomic anion. So again, monoatomic cation, monoatomic anion. If it's more than 1 atom in a group, then you have what are called polyatomic ions. Polyatomic just means there's a group of charged atoms, and they tend to act as a unit. And when I was in chemistry, I had to learn all of these because there's about 5 or 6 of them that always act this way. But examples would be things like ammonium. Okay, so if I put water or ammonia in water, the ammonia takes a hydrogen proton off of the water, and that's how I end up with NH4+. Okay, it gained a proton. It didn't lose an electron, which is kind of weird, but it gained a proton. It gained 1 positive charged particle. And so this would be a polyatomic cation, okay, because it's positively charged. Hydrogen sulfite gains an electron. So it gains a negatively charged particle. So HSO3 negative is a polyatomic anion because it's negative. So we can kind of mix and match those categorizations of ions. And we'll get more into ions as we go. So ions are one form of type of matter. Another type would be a compound. A compound is described as something that consists of 2 or more atoms that get chemically combined by definite proportion by mass. The definite proportion by mass is not something you really need to worry about because we're not going to go through those kind of things. But it's any time that 2 things come together chemically and become something completely new. There are different types of compounds that we run into in inorganic chemistry. An example of one type of compound is an acid. Now there's different definitions of acids and bases, which we'll get into in a different section, but by and large the basic concept of an acid or an Arrhenius acid as it's defined is something that donates a hydrogen plus ion. Now when I donate a hydrogen plus ion, hydrogen again is 1 proton, 1 neutron, 1 electron. So this hydrogen ion has lost its electron. That's why it's positively charged. So it increases the hydrogen ion H+ concentration in a solution. And this happens quite a bit when you put, for instance, an acid into water. The water will steal one of the electrons off of the hydrogen, and you end up with these H+ concentrations. So, for instance, hydrochloric acid, that's an acid. Sulfuric acid, that's an acid. If I put hydrochloric acid in water, this hydrogen comes off, but the chlorine keeps the electron off of that hydrogen atom. And so you have this hydrogen atom that's floating around with no electron. It doesn't just float around by itself. Eventually it's going to attach to a water molecule. But again, we'll see that later. So in this concept, if I have acids that donate a hydrogen ion, that hydrogen ion is just not going to float around just willy-nilly by itself. It's going to attach itself to something. And when it does, it's going to attach itself to a molecule, and that molecule is described as a base. A base is something that accepts a hydrogen ion. So for instance, if I put this hydrochloric acid in water, that hydrogen plus ion, that hydrogen cation comes off, and it's going to attach to the water molecule. The water molecule becomes the base. And so when it does that, it's going to increase the hydroxyl concentration in solution. So in different aspects, and again, there's different definitions of acids and bases just looking at different definitions. But for instance, potassium hydroxide, that's a base. That hydroxyl concentration, that hydroxide, OH, that's what it's called hydroxide, pops off and kind of does its own thing. Ammonia does the same thing. Ammonia, when it goes into water, steals a hydrogen ion from the water, and you end up with OH negative concentrations floating around. I will put up a animation of this. Maybe I'll try to develop it. Now, if I mix an acid and a base, that's called a neutralization reaction. And what comes out of that is a salt. So mixing acids and bases together gives you salt and water. That's always what comes out of it. One definition of a salt is that it's an ionic compound formed by replacing one or more hydrogen ions of an acid with a different cation. So again, cations are positively charged molecules. This hydrogen ion is a cation. I'm going to replace that hydrogen in an acid with something different. So for instance, if I put hydrochloric acid and mix that with sodium, and now this is not necessarily a balanced equation, don't worry about that. But the hydrochloric acid mixes with a sodium cation, and that sodium is going to take the place of that hydrogen, and I end up with NaCl, or table salt. Now, when I take salts, so for instance, this sodium chloride, table salt, and I put it in water, it becomes something called an electrolyte. So most salts are very strong electrolytes. And what they mean by electrolytes is that when I put this in water, it comes apart. The sodium ion will come off and the chlorine ion will come off. It'll be sodium Na plus and Cl negative. And they dissociate, they ionize, they come apart in water. The definition of an electrolyte is any solution that has a solute that produces ions in the solution. So again, when I put the sodium chloride in, or the salt, table salt, in water, what I'm going to get is a sodium cation and a chlorine anion. They've dissociated. Dissociate means to come apart. They've ionized. They've come apart into ions. And what's important about that is that electrolytes allow for the conduction of electricity. You may have heard the term electrolyte in things like Gatorade. Okay, well, Gatorade, if you ever taste Gatorade, it tastes kind of salty. It's because there is salt in it. Because when you sweat, you not only sweat out water, but you sweat out electrolytes. You need sodium and potassium and things like that to make your nerves fire right. That's why if you're dehydrated, they don't give you water. They give you salt water or saline if you had to get it IV. And that's because you need to replenish your electrolytes, because that allows the conductivity of electricity through your neurological system. For instance, water, for instance, is a terrible conductor of electricity. And most people think that's crazy. You know, you get into a bathtub and you throw a toaster oven in there with you, you're going to electrocute yourself. True, but only because you got in the water yourself. So if you take water that is pristine, so uh, distilled water, nothing in it, it's pure water, that will not conduct electricity at all. But when you get in the water, the salts off of your skin become an electrolyte. And then when you put the toaster in it with you to commit suicide, that allows the electricity to pass through the electrolyte of the water and then get into your body. So that's what electrolytes are. They're things that, solutions that will conduct electricity. Another type of compound is an oxide. We don't deal with oxides very often, but you know oxides because you've come into contact with them. You just may not know you did. An oxide is defined as anytime oxygen combines with another element. Now, there are different types of oxides. There are non-metallic oxides. It's created when oxygen reacts with a non-metallic element. So the elements on the right side of the periodic table. So for instance, silicone. Silicone mixed with two oxygens will give you silicon oxide. Okay, that's a non-metallic oxide. Probably not too familiar with that, but silicon oxide is actually sand. The metal oxides are what most people are familiar with. These are created by a reaction with oxygen and a metallic element. So something on the left side of the periodic table. An example would be calcium oxide. Okay, I mix calcium with oxygen, I get calcium oxide. Now, what you might be more familiar with is ferrous oxide or iron oxide. You mix iron with oxygen, what do you get? You get rust, and that's a metal oxide. So those are the main types of compounds. Acids, bases, you mix an acid and a base, you get a salt, and oxides. Those are kind of the four main categories of compounds. Now we can also have mixtures in chemistry. A mixture is not stressed, not chemically combined. A mixture is just a combination of two or more substances in which each substance retains its own chemical identity. If I mix sugar and salt, okay, well, they don't magically become and chemically combine to become something different. They stay sugar and salt. And technically, I could separate them again physically. Okay, that's a mixture. When you talk about mixtures, there's two main categories of mixtures that you run into. There's a homogeneous mixture. Homo means the same. So homogeneous, that's a uniform composition of two or more substances throughout the mixture. So an example of that is if I dissolve salt in water. It's going to have an even distribution of salt throughout the water. I could also have what's called a heterogeneous mixture. Hetero meaning separate or different. That is not a uniform concentration. So for instance, if I take gravel and then I put sand on top of it, okay, well, it's not going to be homogeneous. There's going to be a lot more gravel, especially if I put sand in first and then put the gravel on top. There's going to be a little bit of the gravel that mixes with the sand at the very top of the sand. But if you look at it in a jar, you're going to have sand on the bottom, gravel on the top. That's a heterogeneous mixture. One example of a heterogeneous mixture is something called an emulsion. Emulsion is a mixture of two insoluble liquids. Okay, an example of an emulsion would be one that most people run into is Italian dressing. Italian dressing is a mixture of oil and water. Okay, oil and water don't mix, and if you ever see real Italian dressing, there's always going to be the oil on top, the water usually is on the bottom. So what do you got to do with it? You got to shake it up. Why? Because that will then suspend the oil in the water. Okay, and so when that happens, when you shake it up, you get one of these liquids being dispersed throughout the other in very small droplets. And so you don't end up with a bunch of oil on your salad. You shake it up, and you'll get both the oil and the water. That's an emulsion. You'll see emulsions later when we talk like emulsifiers, things that allow two insoluble liquids to mix together. Some examples of mixtures would be things like air. The people think that air is just oxygen. It's not. It's mostly nitrogen. There's nitrogen, there's oxygen, there's hydrogen, there's carbon dioxide, there's carbon monoxide. There's all kinds of stuff in air. Embalming fluid is a mixture. Embalming fluid, when we mix the chemicals together, do not chemically react. They just kind of suspend themselves in each other. Even blood is a mixture. Your blood has erythrocytes and platelets and monocytes and leukocytes all suspended in plasma. And so they're not compounds, they are mixtures. Okay, so that finishes it up for this section. Next time, we are going to go over the anatomical bonding of atoms.